Hi guys, so last week we learned when we took a monomial we were able to multiply it by a binomial or a polynomial. This week we're going a little bit further. We're going to take two binomials and we're going to multiply them. And then we're going to take a binomial, we're going to multiply it by either a trinomial. In this case we're just going to do a 4-term polynomial. So when you're multiplying two binomials together, we can use something called the FOIL method. So in the notes, we labeled the FOIL method, right? F means our first terms. So the F means we're taking our first terms from these two binomials and we're multiplying those together. Okay, I'm going to label it in the blue. So I would have x to the third times 2x. Okay, and in between every time we're distributing, right, we're going to add a plus sign in there. Okay, so that was our F, right? Our O means our outer term. So our outer terms are this first term here and the last one, the one on the outside of these. All right, so in this case, now we're taking x to the third power and we're multiplying it times 3. Okay, it's going to be this section here. And that I'm trying to do in purple here. So the outer terms are the first on the first binomial, the last on the second binomial. The I in our FOIL method, right, are our inner terms. So I'm going to take this -8 and this 2x. That's going to be my I here. I'm multiplying those inner terms, right? So taking -8, multiplying it by 2x. In between, again, between each multiplication here, we're adding. So our last terms, right, our L, are my -8 and my 3. So I'm multiplying these last terms here, right? That's my L and my green. So my L is my -8 times my 3. Okay, so that's my FOIL method. It's just giving us a way to distribute our first binomial, right? So I'm taking my first term, I'm distributing it to the first term of my second binomial, distributing it to the last term of my second binomial. Then I'm taking this other term. I'm taking it and I'm distributing it to the first term. Then I'm distributing it again to my second term. So from here, I'm going to multiply all of these out, right? And then I'm going to see if I can combine them at all, right? So when I'm doing x to the third times 2x, we're really just multiplying 2 times x to the third times x, right? I'm just adding my exponents here. So I end up with 2x to the fourth. Okay, and again, I have my addition symbol in between. Here, right, if I have 3 times x to the third, right, I just have 3x to the third. Okay, then I have -8 times 2x, right? I multiply these together, -8 times 2, that's going to give me -16x. And my last one, -8 times 3, we'll get -24. So going through our final answer here, all of these terms are different. Right? My first term has an x to the fourth, x to the third, and x, and then no x's. So none of these are like terms. I can't combine any of these together. Okay? If there was a case where one of these were like terms, then I would combine them and get a simplified answer. So that's our FOIL method. You're pretty much taking your first term, distributing it twice. Then you're taking your second term, distributing it twice as well. Okay? And the number 2 here, pretty much we're doing the same idea. So I'm going to start with this x, and I'm going to distribute this x to every single term in my polynomial over here. I need to make sure I hit every single term. So I'm saying, taking this x, I'm multiplying it by 2x to the fourth. Then I'm adding, and I take this x, and I distribute it to the -3x to the third. And then I take my x and I distribute it to the 2x squared. And then I take it again and I finally multiply it by the -5. Oops. That's my multiplication symbol here. Okay. So that takes care of my first term in my binomial. Okay, my second term, I have a +7. I'm going to take my +7 now, and then I'm also going to distribute it to every single term in here as well. So we're taking 7 times 2x to the fourth, right? Then 7 times -3x to the third, and then 7 times 2x squared, I have to write it really small off to the bottom here, right? And then I have 7 times negative 5. So I took my first term, distributed it to everything. Then I took my second term, distributing it to everything. So from here, I end up with this big long mess. I need to simplify a little bit, right? So x times 2x to the 4th, that's going to give me 2x to the 5th. I add my exponents. X times negative 3x to the 3rd, we're going to have negative 3x to the 4th. Then I have x times 2x squared. That's going to give me positive 2x to the 3rd. Then I have x times negative 5. That gives me negative 5x. Keep going, right? Now I have 7 times 2x to the 4th. That gives me 14x to the 4th. 7 times negative 3x cubed. That gives me negative 21x cubed. 7 times 2x squared is going to give me positive 14x squared. And finally, our last term, we have 7 times negative 5, which will give me negative 35. So above, once we had multiplied everything out after we distributed, I didn't have anything that were like terms that I could combine. In this case, I do, right? If I start with the highest power, I have 2x to the 5th. If I keep looking, I don't have another term that contains an x to the 5th. So that's going to start off my final answer, my final polynomial. I'm going to cross it out so that way I know I had already used it. Now I have negative 3x to the 4th, right? I also have this 14x to the 4th. So these two circled terms here are like terms. So really when I have my like terms, my x to the 4th doesn't change. That's still going to stay as my base. I'm just adding or subtracting my coefficients, okay? In this case, we're doing negative 3 plus 14. We're going to get positive 11x to the 4th. And again, I'll cross those out so we know we used them. Then we go down an exponent, right? So I start with my 2x to the 3rd. Keep looking. I also have a negative 21x to the 3rd. So again, the x to the 3rd stays, but we're just adding our coefficients. So 2 minus negative 21 is going to give us negative 19x to the 3rd. So that takes care of those terms. Okay, I have an x squared over here, right? I can count down, so I'm going to keep 14x squared. That goes away because there's no other term left that contains an x squared. So I'm going to count down again. I'm going to keep my 5x, my negative 5x. Okay, and then I have minus 35 at the very end. Okay, so this is going to end up being my final answer. Once I multiplied everything out, I combined all my like terms to get this final polynomial that doesn't have any like terms in it. So this is going to end up being my final answer. So the biggest thing to remember, just like when we were multiplying a monomial by a polynomial, we were distributing that outside term to everything inside these parentheses. When we have a binomial and we multiply it by anything else, we're taking the first term and distributing it. Then we also have to take the second term and distribute it as well. And again, once we distribute in between every distribution, we have an addition sign. So you'll notice up here, right, I took the negative with the 8. So I always distributed a negative 8. Okay, down here, I said when I distributed the x and the 7, I said it was to a negative 3. So that's where our negatives will be included. Other than that, email me if you guys have any questions. Like I said, just remember it's just a lot of distributing and simplifying.